MarielPrice is a third-year PhD student in chemistry who will be giving our next presentation. And Mariel knew they wanted to study chemistry when they started making potions from their mom's garden clippings with kitchen spices. The presentation title is Designing Plastics with a Circular Life Cycle.
Plastics, one of the pillars of modern society. They've helped us make our cars lighter and faster. They've enabled us to preserve produce like meat and dairy to help extend their shelf life and keep food waste out of landfills. Most of our clothes, shoes, and a lot of our electronics are made from plastics, and the list goes on. Mass production of plastics began in the early 60s. Since then, approximately 6.3 billion metric tons of plastic waste has been produced. That's nearly equivalent to the mass of 900 million elephants. No wonder plastic pollution is considered to be such a heavy topic. Of all that plastic waste that's been produced, about 79% has been landfilled, 12% incinerated for energy, and a mere 9% has been recycled. To make matters worse, of that small fraction of plastic that actually makes it to a recycling facility, the majority is downcycled into materials of lesser value. What a waste. So why do we recycle so little? And when we actually recycle, how come the material is downcycled into a material of lesser value? It has to do with how plastics are made. Currently, making plastics is like building with Legos. Imagine Legos as the chemical building blocks that plastics are made of, and the final Lego masterpiece as the plastic material being made. Currently, plastics are made by gluing those building blocks together with superglue, which certainly makes a really strong final product, but then those chemical building blocks can't be recovered at the end of the plastic's useful life to make a new product, so the plastic is discarded. This linear life cycle for plastics is unsustainable and has detrimental consequences to both our health and the health of the environment. Through my research, I aim to develop plastics that have a circular rather than linear life cycle, that are truly and infinitely recyclable. To accomplish this goal, my aim is to redesign plastics so they can be built through reversible chemical linkages rather than by irreversibly gluing the building blocks together. Making plastics without that super glue means that at the end of the plastic's useful life, the valuable building blocks used to make it can be recovered and a brand new high quality material can be made. Recovering the building blocks from plastic waste helps create economic incentive for recycling. If we can either make or save money through the same vein that helps keep plastic waste out of landfills and out of the ocean, we are on the right track. Plastic is an irreplaceable material in modern society, but we cannot allow its current linear life cycle to continue. Developing plastics with a circular life cycle is the solution to keeping them out of the environment and in our lives. Thank you.